So, hello everyone. This is a part 3 of the function chapter in which I am discussing all the important question of the function. And I hope so that you would have go through the part first and part second of the function in which I have discussed some important question and the concept of the function. Now in this chapter I am also discussing the previous year question of the chapter. So the first chapter is a function f is defined from R to R. If a function is defined from R to R is defined by fx is equal to 1 minus x square by 1 plus x square, then then show that f tan theta is equal to cos 2 theta. Now see the solution of that question. So the function is given fx is equal to 1 minus x square upon 1 plus x square. So what we have to find? We have to find f tan theta. So in place of x, I am putting tan theta. So 1 minus tan square theta upon 1 plus tan square theta. Now break tan theta into sin theta cos theta. So 1 minus sin square theta upon cos square theta upon 1 plus sin square theta upon cos square theta. Beta cos square. 1 minus sin square theta upon cos square theta upon 1 plus sin square theta upon cos square theta. Now take the LCM. So you will get f tan theta is equal to cos square theta minus sin square theta by cos square theta upon cos square theta plus sin square theta by cos square theta. Now this term will be cancelled. Sin square theta plus cos square theta is equal to 1 and cos square theta minus sin square theta we have get. And the formula of cos square theta minus sin square theta is equal to cos 2 theta. So that was your answer. Okay. Now the next question is, if fx is equal to 2x minus 1 comma gx is equal to x plus 1 by 2 for all x belongs to R, then find g of fx. Okay. So what is fx here? Fx is equal to 2x minus 1. And what is gx here? Gx is equal to x plus 1 by 2. Now we have to find g of fx. G of fx means g fx. What is the value of fx? 2x minus 1. So 2x minus 1. In place of x, we have to put 2x minus 1. So what is in RHS x plus 1 by 2? So put f in place of x 2x minus 1. So 2x minus 1 plus 1 by 2. So minus 1 plus 1 cancel. 2x by 2 is equal to x. So g of fx will be x. Okay. Now next question is, If f is equal to 1 comma 2 comma 2 comma minus 3 comma 3 comma minus 1, then find 2f and second f square. Now see the solution. F is 1 comma 2, 2 comma minus 3. That means if you put 1, so you will get value 2. If you put 2, so you will get minus 3. If you put 3, so you will get minus 1. Now for 2f, 2f means the second term will be multiplied by 2. So 1 comma 2 into 2 comma 2 comma minus 3 into 2 comma 3 in comma minus 1 into 2. So you will get 1 comma 4 comma 2 comma minus 6 comma 3 comma minus 2. Why I multiply by only second term by 2? Because suppose if a function is given like f1 equal to 4, so what will you do if it was given 2f1? So 2f1 means 4 into 2, that was 8. So here 1 comma 4 and here 2 in 2f is 1 comma 8. So that's why I have multiplied only by second term, because second term is the image. If that something is multiplied with the function, so we have to multiply with the image. Okay. Now second is f square. So for f square means we have to square the second term. So f square is equal to 1 comma 2 square 2 comma minus 3 whole square comma 3 comma minus 1 whole square. So what will you get? 1 comma 4 comma 2 comma 9 comma 3 comma 1. Now come to the next question. If fx is equal to x plus 1 upon x minus 1, then find f of fx. Now what is fx? X plus 1 by x minus 1. So f of fx we have to find. Now firstly find this part, f of fx. F of x means f fx. So what is the value of fx? X plus 1 upon x minus 1. Now f of x means you have to put this value x plus 1 upon x minus 1 in place of x. So you will get f x plus 1 upon x minus 1 plus 1 upon x plus 1 x minus 1 plus 1. Now take the LCM. So you will get x plus 1 plus x minus 1 upon x minus 1 upon x plus 1 plus x minus 1 upon x minus 1. Now this term will be cancelled, minus 1 cancel, minus 1 cancel. So you will get 2x upon x. Wait just a minute. Here is minus sign. x plus 1 minus x plus 1 upon x minus 1. So that term will be cancelled. So minus x will be cancelled by x. So 2x by 2. That means you will get x. So f of x is equal to x, and we have to find f of fx. So f of fx we have to find. That value is x. So f of x is equal to x plus 1 upon x minus 1. That means fx will be your answer. Now come to next question. Next question is, if f is from r minus 0 to r is defined by fx is equal to x cube minus 1 upon x cube, then show that fx plus 1 upon fx, sorry, fx plus f1 upon x is equal to 0. Now come to the solution. We have given that fx is equal to x cube minus 1 upon x cube. So what is the value of 1 upon x? So in place of x, I have to put 1 upon x. So 1 upon x cube minus 1 upon x cube means 1 upon x cube minus x cube. So fx plus 1 upon fx is equal to f1 upon x is equal to the value of fx is x cube minus 1 upon x cube plus 1 upon x cube minus x cube. So that term will be cancelled. So you will get 0. Now second, you have to find the domain of the real value function. Find the domain of the real valued function fx is equal to 2x square minus 5x plus 7 upon x minus 1, x minus 2, x minus 3. Now see the solution. For the domain, the denominator of the function cannot be 0. Okay. If the function is defined, real valued function, if that means the function will be defined, so the value of denominator cannot be 0. So x minus 1, x minus 2, x minus 3 does not equal to 0. So if x minus 1 does not equal to 0 means, so x does not equal to 1, and if x minus 2 does not equal to 0, then x does not equal to 2. So if x minus 3 does not equal to 0, so x does not equal to 3. So the for function to be defined, so the value of domain is belong from r minus 1 comma 2 comma 3. That means we do not have to put the value of x as 1, 2, 3, and we can put any value of x in the real number except 1, 2, and 3. Now come to next question. Now see the next question. If f is from a to b, g is from b to c, are any two bijective function are any two bijective functions, then then prove that GOF from A to C is also a bijective function. Now see the solution. It was given that f is from A to B and g is from B to C. Now what is g of f? G of f can be defined from A to B. F is from A to B, then g is from B to C. So g of f is defined from A to C. Okay. Firstly, the domain of first function come and the range of the second function will come. Okay. So g of will be from A to C. So first we have to prove that g of is bijective function. So for that, wait, just a minute, bijective. So firstly, we have to prove one. So prove GOF from A to C is one. Let A1 comma A2 belongs to A. I am taking two elements of the domain A. So G of F of A1 equal to GOF of function A2 are equal. What is the method of to prove the one function? In that we have discussed earlier. The firstly we have to take fx1 equal to fx2. Then we have to prove x1 equal to x2. So g of f of a1 equal to g of f of a2. So g f a1 equal to g of f a2. We know that the function is given 1 f a to b b to c are any two bijective function. Bijective means they are both 1 and on 2. So f a1 equal to f a2 because g is 1 and a1 equal to a2 because f is also 1. What is mean the g is 1 g is 1 means gx1 equal to gx2. So x1 equal to x2. And what is the f is 1? So what do you mean by it? That if fx1 equal to fx2, so x1 equal to x2. So that why if g of f of a1 equal to g of f of a2, so f a1 equal to f a2, so a1 equal to a2. Clear? Now next is to prove g of f from a to c is onto. So for that we have to take an element from the range. Let's c equal to c. C belongs to c. Small c belongs to c. And since g is from b to c is a bijection function, if a function is bijective function, so what did it means that 1 it was 1 and onto. That means g is also 1 g is also onto. So there exists B belongs to B such that B belongs to B means any element for which GB equal to C will be defined. And since F A to B is a bijective function, so there exists A belongs to A such that F A equal to B. Okay. Now we have taken C is equal to G of B. So B is G of F of A. So G of F of A equal to C. That means there exists an element A belongs to C. Sorry, there exists an element A belongs to A in the domain of G of F such that G of F equal to such that G O F of A equal to C. So G of F from A to C is 1 1 and G of F from A to C is on 2. So G of F from A to C is bijective function. Bijective, okay? You can write here, write there bijective. Now next is if fx equal to 2x minus 1 comma gx is equal to x plus 1 by 2 for all x belongs to R two functions are two functions, then find first g o f of x and second f of g of x. Now come to the solution. First is g o f x means g of f of x. So what is fx 2x minus 1? So g of 2x minus 1. So in place of the gx you have to put 2x minus 1. So 2x minus 1 plus 1 by 2. So you will get 2x by 2 x as answer. Now second is f of g of x which is equal to f of gx. So f of gx is x plus 1 by 2. So in place of x you have to put x plus 1 by 2. So 2 into x plus 1 by 2 minus 1. So x plus 1 minus 1 is equal to x. Okay. So both have the value x. Now next is find the domain of the real valued function fx is equal to 1 upon cx minus x square minus 5. So for the function to be defined, so denominator cannot be equal to 0. So cx minus x square minus 5 does not equal to 0. If you take minus common, so you will get x square minus cx minus 5 does not equal to 0. So x square minus 3x minus 2x minus 5 equal to 0, does not equal to 0. So x, sorry, this can be break in the 5x plus 1 minus 5x plus 1. So x square minus 5x minus x plus 5 does not equal to 0. So if you take x common from the first part, so you will get x minus 5, and minus 1 common from the second part, so you will get x minus 5 does not equal to 0. So x minus 1, x minus 5 does not equal to 0. It means that x does not equal to 1 and x does not equal to 5. So you can take any value of x in the function R, but not 1 and 5. So the domain will be x belongs from R minus 1 upon 5. Now the question is, if a equal to minus 2, minus 1, 0, 1, 2, and f is from a to b is surjection defined by fx is equal to x square plus x plus 1, then find b. We know that a is equal to minus 2, minus 1, 0, 1, 2, and fx is from x square plus x plus 1. So if you take minus 2, so you will get minus 2 whole square minus 2 plus 1. It means 4 minus 2 plus 1, 5 minus 2 is equal to 3. So f of minus 1 is equal to minus 1 whole square minus 1 plus 1. So 1 minus 1 plus 1 is equal to 1. So f of 0 equal to 0 square plus 0 plus 1 is equal to 1. Okay. Now f of 1. F of 1, you will get 1 square minus 1 plus 1. So on solving, you will also get 1. F of 2. On solving f of 2, you will get 2 square minus 2 plus 1 plus 2 plus 1. So 4 plus 2 plus 1 equal to 6. Okay. Now the next question is, find the domain, find the domain of real valued function fx is equal to under root 4x minus x square. So if the function is real value, that means that value cannot be in the imaginary. So for the imaginary, that value will always greater than equal to 0. So 4x minus x square always greater than equal to 0. So if you take minus common, so you will get x square minus 4x will less than equal to 0. Okay. Now if you take common x, x minus 4 less than equal to 0, which means that x is belongs to 0 to 4. So the domain of the function will be 0 to 4. The domain of f is from 0 to 4. These two questions are repeated one more times, huh? Important for the exam point of view. So the next question is, find the domain of real valued function. Find the domain of a real valued function fx is equal to 1 upon x square minus 1 and x plus 3. So for domain, the denominator cannot be 0. So x square minus 1 x plus 3 does not equal to 0, which means x minus 1 x plus 1 x plus 3 does not equal to 0. So x does not equal to 1 minus 1 minus 3. So the domain of the function is from r minus 1 minus 1 minus 3. Now the next question is, if f is equal to 4 comma 5, 5 comma 6, 6 comma minus 4, and g equal to 4 comma minus 4, 6 comma 5, 8 comma 5. So we have to find f plus g. Second is 2f plus 4g. Third is f plus 4. Fifth is f upon g. Sorry, fourth is f upon g. Fifth is under root f. Sixth is f square. And seventh will be mod f. So how we can find? Now f is equal to 4 comma 5, 5 comma 6, 6 comma minus 4, and g is equal to 4 comma minus 4, 6 comma 5, 8 comma 5. Now the domain of f is, what is the domain of f? The second value, 5, 4, 5, 6 and minus 4. I think the question is given wrong in the book. This term, this is taking that 5, 4, 4, 6. So you have to change that value. That question is given wrong in the book. It must be like 5 comma 4, 6 comma 5, and minus 4 comma 6. And the value of g is also given in the reverse order. Minus 4 comma 4, 6 comma 5, 5 comma 6, and next 5 comma 8. The value of f is 5 comma 4 comma 5 comma 6 comma 5 comma minus 4 comma 6, minus 4 comma 6, and the value of g is minus 4 comma 4, 5 comma 6, and 5 comma 8. So what is the domain of f? 4, 5, and 6, and what is the domain of g? 4, 6, and 8. So the domain of f is 5, 4, 5, and 6. 4, 5, and 6. And the domain of g is 4, 6, and 8. Now the domain of f intersection g is from f4 comma 6. Okay, so the intersection part will be 4 comma 6. Once again, I have to check. Just a minute, it is given domain. So I think that we have written rightly first. Sorry. Sorry, student. The firstly we have right. Question is f is equal to 4 comma 5 comma 5 comma 6 comma 6 comma minus 4, and g equal to 4 comma minus 4 comma 6 comma 5 comma 8 comma 5. Because in this question I not seen that the domain is given. So the domain of f is from 4 to 5, 5 to 6, 6 to minus 4, and the g is from 4 comma minus 4, 6 comma 5, 8 comma 5. Sorry for my mistake. I have seen I have written the wrong one. Okay. So the domain of f intersection g is from 4 to 6. Now the first part is we have to find f plus g. And last one is mod f. So first is f plus g. So first part we have to find f plus g. So f plus g of 4, f plus g of 4, because only there are two terms. So f of 4 plus g of 4. So what is f of 4? That if we put domain as 4, so we will get 5. And if we take g of 4, then we will get minus 4. So f of 4 is 5 and g of 4 is minus 4. So 5 minus 4 is equal to 1. Now second, f plus g equal to c. So f of 6 plus g of 6. So f of 6 is equal to, means if you put 6, so you will get minus 4. If you put 6, so you will get 5. So minus 4 and g of 6 is 5. So 5 minus 4 is also 1. Now come to the next part. Second one is 2 of f plus 4 of g. 2 of f plus 4 of g. Now the first part is 2 of f plus 4 of g of 4. So 2 of f of 4 plus 4 of g of 4. So f of 4 is, if you put 4, so you will get 5. And if you put g4, so you will get minus 4. So is equal to 2 into 5 plus 4 into minus 4. So 2 5 is 10 minus 16. So you will get minus 6 as answer. Now the second part, 2 of f plus 4 of g. Of the next part, what is the domain of f intersection g is 6. So 2 of f plus 4 of g of 6. So you will get 2 of f of 6 plus 4 of g of 6. So f of 6 is given, f of 6 is given as minus 4 and g of 6 is given as 5. So minus 4 plus 5. So 2 into minus 4 plus 4 into 5. So 2 into 4 minus 8 plus 20. You will get 12 as an answer. Similarly, you can solve all the part f plus 4. You can solve f upon g. You can solve under root f. Next f square. And last one mod f. Okay. So that was your answer and that was your homework. If you didn't solve, then you can write in the comment box. I will solve in the next part. Okay. Now write second one. Now the right second question. If A comma B belongs to R and F is from R to R, defined by Fx is equal to Ax plus B, where A does not equal to 0, then find F inverse. Find F inverse. Now see the solution. Let Fx equal to Y. So Ax plus B equal to Y. Okay. So Ax is equal to Y minus B. So X is equal to Y minus B upon A. That means that the value of F inverse X is X minus B upon A. Okay. Now come to the next part. Question is given. If F is from R minus plus minus 1 to R is defined by Fx is equal to Fx is equal to log mod 1 plus x upon 1 minus x, then show that f of 2x upon 1 plus x square is equal to 2 times of fx. Now come to the solution part. Fx is equal to log 1 plus x upon 1 minus x. Now put 2x plus 2x upon 1 plus x square in place of x. So f upon f 2x upon 1 plus x square is equal to log 1 plus 2x upon 1 plus x square upon 1 minus 2x upon 1 plus x square. So you will get log mod of 1 plus x square plus 2x upon 1 plus x square upon 1 plus x square minus 2x upon 1 plus x square. So that term will be cancelled. So you will get log x square plus 1 plus 2x plus 1 and x square minus 2x plus 1. So in numerator you will get the formula of log x plus 1 whole square and denominator log x minus 1 whole square. So the formula will become value will become log x plus 1 upon x minus 1 whole square, which is equal to 2 times of log x plus 1 upon x minus 1. So that is the value of fx. So 2 times of fx is equal to f of 2x upon 1 plus x square. We have proved. Now come to the next question. Find the domain of real valued function fx is equal to under root x square minus 25. So for real value, the value of x square minus 25 is always greater than equal to 0 because it does not take any imaginary value. Okay, so x square minus 25 greater than equal to 0. That means x minus 5, x plus 5 is always greater than equal to 0. So you will get x belongs to minus infinity to minus 5 union 5 to infinity. Now come to next question. If f is from R to R and g is also from R to R are defined by fx is equal to 3x minus 1 and gx is equal to x square plus 1. Find f of g of 2. F of g of 2. Now come to the solution. F of gx, which means f of x square plus 1. So 3 into x square plus 1 minus 1. So 3x square plus 3 minus 1. So 3x square plus 2 will be the value of f of g of x. Now in place of x you have to put 2. So f of g of 2 is equal to 3 times of 2 square plus 2. 3 times of 2 square plus 2. Remain 3 into 4 plus 1. So 12 plus 2, you will get 14 as answer. Okay. So that are some important question of your function chapter. Now, if any question will be left, so I will come with the next part of the function. Okay. So that's all for today. If you face problem in any question or in any topic, so you can send the question to sir and ma'am. So they will send me. Okay. That's all for today. Thank you, everyone.